Okay, this is a completely different packet. This is one that we started. This was the homework from March 8th. It was Thursday, March 8th. It was a packet of a bunch of questions, and we already did some of them, but this is number 4. It looks something like this, okay? So we did not do this one yet. And this one has area under the axes, so this is really important for us to go over. Okay, so you are supposed to find the integral from -1 to 4 of f of x dx, and this graph is f of x. Okay, so, sorry, I just dropped my iPad. Okay. It's not saying it's an estimate, but we also don't have a function to find an exact value. Well, we're going to get an exact value because each of these shapes that we're going to create are the exact shapes. It's not an approximation. It's not an overestimate or it's not an underestimate. It's an exact amount. So what you have to do is you have to break this into different pieces, and I'm going to do it in colors. So first you're going to start here, and you have this pink triangle. So the area of the pink triangle is going to be 1/2 base times height, just the regular area formula. So the base is 1, because it goes from -1 to 0, and the height is 2, because that's what it shows on the graph. So 1/2 times 1 is 1/2, 1/2 times 2 is 1. So the area of that piece is 1. Okay, let me get another color. Okay, next we have this shape over here, and this is a trapezoid. Okay, so it's going to be 1/2 base 1, so let's say that this is the base 1 up here. So you're just going to look at your picture, and it goes from 0 to 1, so that's going to be 1, plus base 2, this is the base 2 over here, and that's going from 0 to 2, times the height, and the height is this, and you just have to look at the picture and you can see it's 2. So the 1/2 and the 2, those will cancel each other out, and you have 1 plus 2, and that equals 3. Okay? Next, the next shape we have is a triangle. Well, actually, it's a trapezoid. Okay, either you could do a triangle and a rectangle, or you could do a trapezoid. I guess I'll do the trapezoid. I didn't even realize that it was a trapezoid. And I'm going to do that in this ugly Easter green color. Okay, so we're going to have 1/2. Okay, so base 1, we'll say, is this piece down here, and that goes from 3 to 4, so that's equal to 1, plus base 2 is up here, and that goes from 2 to 4, so that's 2. And this is our height this way, which was from -1 to 0, so that's 1. And we get 1/2 times 3 equals 3/2. Now, this is the new thing that you haven't learned yet. If you are below the axes, then your area is negative, so you must put a negative there. So important, don't forget that. Okay, so you might be saying, how can area be negative? So it's not like you're finding the area of the trapezoid. Obviously the area of a trapezoid would be a positive value, but put this in perspective in terms of what we've just been doing with how many bananas were on the table, or how much oil was in the barrel, all those kind of things. It means during the time from 2 to 4, this entire piece here, it was negative numbers. So it could have represented that you didn't have any bananas on the table, the more oil is leaking than is being put in. Usually if it's negative, it might be something like profits or people leaving a park or something like that, okay? Okay, so in any case, now we're going to take these 3 numbers and we're going to add them. So we have 1 plus 3 is 4. So we have 4 minus 1.5, right? Because 3/2 is 1.5. And that will give us 2.5, and that was choice B. Okay, so remember, if the area is under the curve, I mean not under the curve, under the axes, the y-axis, it's always negative. Okay, let's move on to number 5. Okay, so for number 5, you were given a table, and we're going to use, they gave us, we don't have to figure it out, the intervals are going to be 2 to 5, 5 to 7, 7 to 8, and we have to do a trapezoid, okay? Trapezoid's going from 2 to 8. So let's set it up for 3 different trapezoids. Okay, the height from 2 to 5 is 3. The height from 5 to 7 is 2. And the height from 7 to 8 is going to be 1. Okay, so now we just have to do our bases. So base 1 is going to come from when it's 2. So you look at your table, and when it's 2, it's 10. The next base is when x is 5, which gives us 30. Remember, you're just going to carry that over. Okay, so now we're on the next interval. When the base is 5, we got the 30 already. And when the base is 7, we have 40. Carry the 40 over. And the last one is going to be 20, and now we just have to do this math. So we have 3 halves times 40. 1 half times 2 will just cancel. That will give us 70. And then we have 1 half of 60. So 2 goes into 40 20 times, so we're going to get 60, 70, and 30. And this will give us 160, which is choice C. Okay, the next sheet says 5259 on top. Okay, so we're going to do number 1. And you have 5 pictures, A, B, C, D, and E. Okay, so what it's saying is that if you do a right-hand Riemann sum, so if you do a right rectangle, it will give an over approximation. Okay, so you want it to give you an over approximation. Okay, if you look at A looks like this. Okay, so if I wanted to make right rectangles, let me get another color. So I make my first one, make my second one. You could see this is an under approximation. So that means A could not be the answer. We'll take that out. Okay. Get another color. Okay, let's look at B. Okay, B looks like this. Okay, so we'll close it off. Let's pretend we're making 2 right rectangles. And if I do that, so if I take it from the right, I get this. You can already see it's an under approximation, so it can't be B. Okay. Let's go to C. Okay, C is just a line. So close it off, pretend we're making 2 rectangles. And now if I take it from the right, I get this. Take it from the right, I get this. And that is an over approximation. So C is still in the running. There's a second part to this, so that's why I'm not declaring C as the winner. Okay, let's look at D. So D looks like this. Let's close it off. And if we make right rectangles, we're going to have this. And that is an over approximation, so D is still in the running. And then we have E. Claudia, you still with me over there? We have a picture that looks like this. And we'll shut it off here, and let's say it looks like that. And then we'll, let me get another color. So if I make a right, looks like this. And that would also be an over approximation. So C, D, and E are still in the running, okay? Now let's look at the second part of this. The second part says, if you do a trapezoid sum, it's going to be an under approximation. Okay, so C was still in the running. Let's look at C. So this was C. Let's close that off. And let's make some trapezoids. Well, aren't these exactly trapezoids? So how could this be an under approximation? It's the exact value. So it cannot possibly be C. Okay, let's look at D. Sorry, this is not cooperating. So D looked like this. And now if we make some trapezoids, we'd have this, this, and that. And we'll have that. Oh, I think I did not draw that very nicely. Sorry. Let me get my black color back. Oh, this is a mess. Okay, sorry, I'm just going to redo it. Okay, so it look like this is D. It looks something like this. Try again, because it's not, I'm going to try gray. Maybe that'll give me good luck. Okay, well, something like that. Okay. So if we make, let's say, 2 trapezoids, I'm going to go from here to here. We go from here to here. That looks like it's an under approximation. So I'm going to leave D in the running, and then I'm just going to try E. And E look like this. So let's cut this off. We'll make 2 trapezoids. So I'll have this. And this. Okay, on mine, on the picture I just drew, it's because I'm not drawing it exactly like the picture here. Hold on. Sorry, this is a little annoying. I should have taken a picture of it and like imported it. It's more like this. Okay. Let's cut this off, make my 2 trapezoids. Okay. So here's 1. Here's 2. So we're looking for an under approximation. Okay, my picture is not great, but if you do yours, it will be an over approximation if you use the actual graph that's on choice E. So E would be out, and then D is the winner. Okay, let's go to the next one, which is number... Okay, the next one is 2. I hope things didn't just get screwed up there. I just saw it said resume recording. Okay, so if anything was missing, just let me know. Okay, so we're going to do 4 sub-intervals. So we're going to go from 1 to 1.25, 1.25 to 1.5, from 1.5 to 1.75, and then 1.75 to 2. And we're going to do this, oh my God, using trapezoids. Okay. I'm sure Osman is sleeping at this point. I mean, this is ridiculous. We're doing so much work. Okay. I mean, unless, of course, he's absent. That's always a possibility. Okay. The height for each of them is 0.25, which is 1/4. So let's put those in. Okay, so we're just going to use the table. So we're going to get 5, 8, 8, 4, 4, 4, 4, 11. We'll now do this annoying math. So we get this. Okay, so I'm not simplifying because they're all have a common denominator now of 8. Just be easier. Okay, so we have 13 plus 12 is 25. 25 plus 8 is 33. 48 over 8, which is equal to 6, and that was choice A. And then finally, so we could finish this, the last one, Brianna L., what are you doing? Is everyone, I hope everyone's not out going to the bathroom right now. Okay, so for number 3, here's our picture. We're almost done. It's the last one, I promise. A and B. Give it a color. Okay, we have 5 choices. Okay, so which is false for this? Okay, so let's just do one thing at a time. So if we do a left sum, we're going to look like this and like this. Okay, so a left is an under approximation. Okay, we're going to just have to figure everything out here. Okay, if we do a right, it's going to be an over approximation. So a right equals an over approximation. Then they're asking for a midpoint. So it looks something like this. Okay, so if we made, let's say, 2 rectangles and we take the midpoint, we'll have this and this. Okay, the midpoint, that looks pretty close. So we'll say not sure. And then we have one more. Hang in there. It's a trapezoid. So here's our picture. And so if we made, let's say 2 trapezoids, we're going to look like this. And if on your picture you'll see it's an overestimate. So a trapezoid equals an overestimate. Okay. A says the left, so the left, that's this one, is going to be less than the right. Okay, that is true. But we're not looking for true, we're looking for false. So that's out. Okay, B says the left hand, that's this, will be bigger than the trapezoid. The left hand will be bigger than the trapezoid. No, that wouldn't be either. Okay. Let's go to C. C says the right, so this is an over, is going to be bigger than the midpoint. Well, this is, we weren't sure about that one, so this could be a possibility for C. Let's look at D. D says the trapezoid will be less than the right hand. Well, these are both overs, so we're not, that's probably, if you had to choose between C and D, we're taking D out, because they were both over, and there's no way for us to figure out exactly how much over. And E says the midpoint, which we were unsure of because it was very close, is smaller than the trapezoidal sum. We really can't say, and therefore the answer would have to be C, because C is saying that the right-hand sum would be bigger than the midpoint. So the right one was definitely an overestimate. The midpoint was very close, so the right hand would definitely be bigger than that. And we're finally done, thank God.